Okay, hello, good afternoon everyone. Maayong hapon. Okay, for this afternoon, we will have a short review on the different intramolecular forces of attraction. And then if we still have time, I will also discuss the preliminary parts, writing of Lewis structures. Okay? Sige. So I hope you have with you already your printed handouts, or it's okay if you still have the ano pa yung soft copy of the handouts that I provided to you. Okay, so let me record this session. Ayan. Okay. Now, when we talk about intramolecular forces of attraction, that is synonymous to the term bonds. Okay? Yan din, yan din lang din yung bonds, chemical bonds. Okay? That connects atoms or molecules together. Yan yung forces of attraction. When we say, ayan, pasensya, ayan. When we say intramolecular naman, intra, ibig sabihin within. Molecular, it has something to do with molecules. No, so, ibig sabihin, yung itatalakay natin na forces of attraction are those bonds within a molecule. Okay, within a molecule. Within a molecule or one molecule. Okay, and there are only two types, no? Two types of intramolecular forces of attraction. Recall that we have ionic tsaka covalent bonding. Okay? Now, yung tanong, bakit nga ba yung mga molecules, they tend to participate chemical bonding? Why do atoms bond? Okay? Class, please recall na atoms tend to form compounds, they tend to participate in chemical bonding because they wanted to attain stability. Tama. That is why it was proposed by Mr. Gilbert. This is Gilbert. Gilbert and Lewis. He proposed that an atom is at its most stable state if its outermost shell is completely filled. Now, how can an atom attain that completely filled outer shell? Or how can an atom attain its uh, 8 surrounding electrons on its atom? Yun na nga, they has to form bond. Paano sila mag-form ng bond? Based on Lewis theory, an atom needs to lose electron, or that's give up electron, or they tend to accept. Ibig sabihin ng accept, they tend to gain, di ba? Or there are also electrons when they participate chemical bonding, they share electrons para ma-achieve yung completely filled outer shell nila. Okay, this Lewis theory, this is also what we call the octet rule. Okay, synonymous lang na sila. Lewis theory is just equivalent to octet rule. Specifically, di ba kapag sinabing octet, yung prefix oct, that is a Greek prefix, di ba, for number 8, di ba, 8. Octet, oct is 8. So, ibig sabihin, yung standard na number of electrons that surrounds an atom na making them stable, it should surrounded with 8 electrons. Okay, yan yung octet rule. Although, yung octet rule, it is not applicable, it is not applicable to all of the atoms kasi we have hydrogen, for instance. Yung hydrogen, hindi naman 8 electrons yung kaya niyang i-hold or i-occupy niya sa kanyang orbital, because recall that hydrogen only has 1 electron. Diba? Yung atomic number niya is 1 for hydrogen. Ibig sabihin, yung number of electron niya is only 1 also. Kaya nga 'di ba yung electronic configuration niya is only 1s1. Now, may I ask you, kapag s orbital, ilan ba yung maximum number of electrons na kayang i-hold ng uh, S na sub-level or S na orbital? Maximum number of electrons. Okay, very good. 'Di ba? Dalawa lang. Ibig sabihin, if you are asked how many is the number of electrons, 'di ba? Na considered na completely filled na yung orbital ni hydrogen. So dapat 2 lang. 2 lang yung electrons yung kayang i-hold ni hydrogen sa kanyang orbital. So hanggang 1s2 lang yan. Yan yung completely filled na outer shell ng hydrogen. So ibig sabihin at that state, stable na si hydrogen. Kasi completely filled na yung orbital niya. Diba? 1s2. Alright? Ibig sabihin na-attain niya yung electronic configuration ni helium. Kasi 'di ba yung mga group 8, if you recall, if this is the periodic table, yung mga itong nasa going to the left, no? Yung nasa leftmost, no, na mga atom, sila yung hindi pa stable. Okay? Unlike group 8. Itong group dito, stable na yan sila. 'Di ba? Yung nasa pinaka-top dyan is helium. Helium, stable siya kasi it has this electronic configuration 1s2. Yan yung gustong i-achieve ni hydrogen. Kaya it tends to gain, 'di ba? It tends to gain electrons, making it 1s2. Okay, so yan yung reason lang po bakit kailangan yung mga atoms, they tend to combine para magbuo yung molecules. They tend to give up, accept, or even share electrons para lang ma-attain yung stable nila na state. Okay, yung stable state is equivalent to completely filled outer shell. Okay? Ayan. So ito yung sinasabi ko kanina. Ito sila, yung mga atoms dito. Okay? Ayan, except sa group 8. Okay? Mga unstable pa yan sila. Kaya they participate, no? They participate chemical bonding. Kaya meron silang usually ion forms, no? Chemical bonding. Okay? Another example, let's say si lithium. Diba? Yung lithium, diba, makikita siya sa anong block to? Is it SPDF? Yeah, I have provided na, diba, the video material. Okay, very good. Diba, ito yung S block. Ibig sabihin, yung last, yung valence electron niya, diba, is found on the S orbital. Tapos, yung last na sub-level niya na makikita when you write its electronic configuration would be based on its period. Okay? So, on its 2s orbital, meron siyang 1 valence electron. Ayan. That is how to write it. Kaniha, ito based sa period, yung 2. Saan siya makikitang period? Diba this is period 1, period 2, period 3, and so forth. O si lithium makikita sa period 2. Ayan yung N value. Okay? And then the S, that is based on its blocking sa periodic table. Okay, sige. Ibahin ko yung kulay. This is S, P, D, F. So nasa S block, makikita yung lithium. Yung 1 dyan, okay, that is based on its group number. Diba? Grouping. Group number nila. This is group 1A. Ayan. Diba? Group 1. Nasa group 1, si lithium. Ito yung mga group 2. Ito yung group 3A, group 4A, 5, 6, and 7. Okay? So, madali lang ma-identify yung valences, 'di ba, ng mga A elements kasi base yan sa groupings nila. Okay? Now, going back to lithium. So, 2s1, on its 2s1 orbital, meron siyang extra, no? Extra na yan sa kanya, extra na yan na electron. Kaya, during chemical combination, 'di ba, yung nangyayari kay lithium, it tend to lose that single electron niya sa 2s orbital. Kaya when it loses electron, may I ask you, is it a positive or negative charge na si lithium? Ano yung ion form ni lithium kapag nag-lose siya ng electron? Metals. Okay, very good. Kaya nga 'di ba, i-recall niyo yung cation form ni lithium. 'Di ba? It's Li plus lithium plus. Okay? So nag-lose siya ng isang electron. So yan yung nangyayari. Okay? So a sort of review lang yan. Okay? So lithium, yan, pasensya na yan. Okay, kaya nagiging, pasensya, ayun. Okay, ayan. Okay. So it will now carry a positive charge. Okay? So, okay, let's have another example ha, si sodium. Si sodium on its 3s orbital, meron ding 3s orbital niya, meron din siyang extra 1 valence electron. Ito, shinortcut ko na ha. You can write the full electronic configuration of sodium. Okay, yung sodium has how many electrons? Diba 11? Okay, so when you write its electronic configuration, so erase ko ha, para lang talaga ma-recall sa lahat. Diba, it's 1s and then 1s, 2s, tama ba? 2p, then 3s. Diba yan yung order. So 2, 2, and then 6, 1. So 11 lahat. Kasi you have to, you have to let that 11 occupied sa orbital. So 11 na lahat. O ayan, ito yung sinasabi ko at its 3s orbital, dyan natin makikita yung valence electron ni sodium. Kasi yan yung pinaka-highest energy level niya, 3. Diba? Sa highest energy level, doon natin makikita yung valence electron. So meron siyang isa, extra na yan ni sodium. Kaya during chemical combination, para maging stable siya, ilulose niya yan, yung isang extrang electron niya sa 3s orbital. Kaya nga 'di ba, ano yung cation form ni sodium? Sige nga, you type in. Ano yung cation form ni sodium? Nagiging Na plus or minus when it loses that one electron. Okay. 'Di ba? Sodium plus, Na plus, ibig sabihin nag-lose siya ng isang electron to make it stable. Okay, that's the reason bakit meron silang mga ion form. Okay, let's have the right side naman na halimbawa. Ito, mga metals yan. So yan yung tandaan nyo, kapag metals, they tend to lose electrons during chemical combination. Halimbawa naman, let's have non-metal. Let's say fluorine. Yung fluorine, since it is found here, di ba, nasa group 7 siya, group 7A. Ibig sabihin, it has 7 valence electron. No? Meron siyang 7 valence electron. So kung isusulat niyo yung electronic configuration ng fluorine, merong isang p orbital. No? Meron siyang isang 2p orbital na walang partner. Okay? Walang pair, no, na electron. Kaya, yung mangyayari kay fluorine during chemical combination, mag-a-accept siya. It's either mag-accept siya or mag-share siya ng electrons. Yan lang yung mga, yung fate niya. Okay, fate niya during chemical combination. Mag-a-accept siya if yung chemical binding niya is a metal. Diba? Halimbawa, let's say a sodium is being reacted to a fluorine. So yung mangyayari, yung sodium, diba, will tend to lose electron. Okay, kung nag-lose siya ng electron, it becomes an A+. The fluoride ion, since meron siyang isang p orbital dyan, you try lang to write the electronic configuration ng fluorine. Meron siyang isang p orbital na walang partner, walang pair. Kaya, it will tend to accept the electron being given by sodium. Kaya magiging F- siya. Diba? Fluoride ion, magiging fluoride ion, forming sodium fluoride. Okay? So, that's the concept. Okay? Sige. So, that's for non-metals. Okay? They tend to gain electrons. Okay? So, when you write it naman, or when you draw the surrounding electrons ng fluorine, if this is fluorine, yun na nga, sabi meron siyang 7 valence electron kasi makikita siya sa group 7. Okay, nasa group 7 yung fluorine. Ito yon. Ayan. Ay, sorry, nawala. Alright. Ayan, ayan. Okay? So, may 7 electron siya. So, you try to represent the electrons ng valence electron. The valence electron ng fluorine sa kanyang surrounding. So, let's say, ayan. So, that is 7 all in all. O, kung titingnan natin, itong hinighlight na kulay red, di ba wala siyang pair? It does not attain yet its octet. Di ba? It's octet state, it's stable state. Kasi dapat may standard yan. Standard na may 8 electrons that surrounds the outermost shell ng atom. Okay, yan yung octet. Kaya yung mangyayari during chemical combination, it will tend to gain electron. Okay? Kapag nag-gain yan ng electron, magiging, ayan, fluoride ion siya. It will now carry a negative charge. Negative 1 lang. Kasi isa lang yung kailangan niyang i-gain para ma-achieve niya yung completely filled outer shell. So it has now 8 surrounding valences. Ganun din kay chlorine kasi parehas lang naman sila, di ba? Nasa group 7. Ganyan din yung mangyayari kay chlorine. It will gain 1 electron. Okay? Kasi meron din siyang 1 p orbital na unpaired. Okay? Ayan. Now let's talk about the 2 types of bonds. Okay? Yung dalawang intramolecular forces of attraction, we have first ionic bonds. So kapag ionic bonds, ions, it involves ions. So dalawa lang naman yung types ng ions, di ba? Merong cation tsaka anion. Kapag cation, positively charged. Kapag anion, negatively charged. Okay? So for a bond to be considered ionic, dapat ito ay binubuo ng isang cation tsaka anion. Okay, there has to be attraction of opposite charges, positive and negative. So yun yung isang halimbawa, yung kanina, yung sodium, okay, fluoride. What connects the two is an ionic bond. Bakit naging ionic bond? It is the sodium that loses 1 electron. Saan pupunta yung na-lose niyang isang electron? I-accept yun ni fluorine, making it a fluoride ion. Okay? Another example, yung sodium chloride, this is a very common example. So, di ba, yung Chloride, meron siyang 7. By the way, this is how you represent electrons uh, surrounding an atom. You only draw its valences, yung valence electron nila. Do not include the core electrons ng isang atom, only the valence electron. Kapag sinabing valence electron, the outermost electrons. Yun yung makikita sa highest energy level ng atom. Okay? Bakit yung mga valence electrons lang yung i-represent? Kasi it's only the valence electron that participates during chemical bonding. Okay? Yung mga electrons na makikita sa innermost part ng atom, they do not participate chemical bonding. Okay, that is why I only draw their valences. Sodium has 1 valence electron, chlorine has 7 valence electron. Okay, kung naglibog gihapon, unsa ganitong valence electron, alantawa ang group number sa periodic table. Ha? If this is the periodic table, these are the A elements. Yan yung mga A elements. Kung ano yung group number nila, nasa group 1 sila makikita, yan yung valence electron nila. Number of valence electron. So si sodium makikita siya dito, 'di ba? Sa group 1, kaya meron siyang 1 valence electron. Okay? Si chlorine nasa group 7, kaya yung dinraw ko na dots 7. Okay, 7 valence electron. When you draw it in pair, okay, you draw that in pair. Okay? So ayun, makikita natin dito na si chlorine, meron siyang unpaired, 'di ba? 1 unpaired electron. Si sodium, isa yung valence electron niya. So during chemical combination, sodium will tend to lose. No, ilulose niya yung isa niyang extra electron. And then, i-accept yung binigay ni sodium, i-accept yan ni chlorine. Okay, forming sodium chloride. This is now a stable compound. Diba? Sodium chloride is a stable compound. Okay, so that's all about ionic compound. These are other example. Ayan, si magnesium chloride. Let's say, erase ko muna dito banda ha. Ayan. Si magnesium, ayan, magnesium chloride, makikita siya sa group 2. Diba? Makikita siya sa group 2 ng periodic table. Kaya, meron siyang, ayan, dalawang extra electron. Okay? Ngayon, if you have 2 chloride, ayan, diba kasi sa written na condensed formula ng magnesium chloride, dalawa daw yung chlorine. So you try to draw, no, chlorine's valences, i-represent mo yung valence electron ng chlorine on its surrounding. Yun na nga, meron silang tig-iisang unpaired, no, unpaired electron. So yung gagawin ni magnesium as a metal, it will tend to, ayan, give up or lose that electron. Kaya, it will now form magnesium chloride. No? Magnesium chloride. Ayan. So, yan yung magiging resulta. Okay, it is now a stable compound. Magnesium chloride is now a stable compound. Ito yung dalawa. Yung kulay blue, ito yung dalawang valence electron ni magnesium. So, binigay niya tig-iisa sa chlorine kasi need nila ng isa para maging stable sila. Okay, so that's for ionic bonding. Now, let's give focus sa covalent bonding naman. Kasi most of the organic compounds, if you try to check the structures ng organic compounds, ang being observed na type of bond, covalent bonds. Okay? Now, when we talk about covalent bonds, what is being observed here is there is only sharing of electrons. Okay? So walang mangyayaring transfer or accepting ng electrons. So purely sharing of electrons lang yung mangyayari. So this usually being observed among non-metals to non-metals. Diba? Kapag you try to interact a non-metal to another non-metal atom, what will happen there since yung dalawang non-metal, 'di ba, they badly need electrons. Need man nila, wala gyud maghatag sa ilaha, so they will just decide na mag-share na lang sila, no, sa ilahang kung unsa ang nasa ilaha. Sa halimbawa, 'di ba, kanina si chlorine, we have discussed na meron siyang meron siyang isang electron na unpaired. And we also mentioned na si chlorine, ang iya ra gyud isa sa iyahang ability is, not ability, ang iyahang fate. So that's the term. Iyahang fate lang gyud is kailangan lang gyud niya na mag-accept. Kailangan siya, kulang man siya, so mag-accept gyud siya. No, kulang man siya isa. Dayon ang gi-interact sa iyaha, the same atom, chlorine, kailangan din, 'di ba? Yan ang isa pang electron. So yung mangyayari, they will just decide to share that unpaired electron. So i-share nila yung unpaired electrons nila. Okay, so yung mangyayari parang ganito, ah, para inyohang ma-visualize. Let's say, ayan, ito yung anim, and then, sige, ayan, unpaired. Yan yung unpaired yan na electron for one chlorine. Then the other chlorine, ayan, ito yung unpaired niya. So yan yung mangyayari, nag-share lang sila. So kung inyohang itry og check per chlorine, ito, it now attains octet. Diba? Itong nasa left side na chlorine, naka-octet siya. Tama? It will now have 8 surrounding electrons. Ganon din sa chlorine on the right side. Na-attain din niya yung stable state niya. Meron din siyang 8, no, na surrounding valence electron. Okay, so share lang yung nangyari. Walang nag-lose, walang transfer of electrons, walang nag-accept. They just share their unpaired electrons. Alright? Ganun din with regards to hydrogen. Okay, so kapag tinanong kayo, yung number of electrons that makes the hydrogen stable, dalawa lang yung electrons, no, na kaya niyang i-hold. Dalawa lang yung electrons na kaya niyang i-hold. Okay? So halimbawa, if this is hydrogen, ayan, diba, meron siyang isang valence electron. Ganon din, yung isang hydrogen, meron din siyang isang valence electron. So yung mangyayari when they tend to interact, they will just share those unpaired electrons nila. So, black na lang. Ayan. And then, kulay blue. So, yan yung mangyayari. They only share their unpaired electrons. So, covalent yan. Purely covalent bonding, sharing of electrons. Okay. The same thing kapag hydrogen to chloride, share lang din yung mangyayari, sharing of electrons. Okay, hydrogen to oxygen, okay, nitrogen, hydrogen, ayan. So yung water, what connects atoms sa water molecule, that's purely covalent. No, that's covalent bond. So halimbawa, this, diba, water, it has one oxygen and then two hydrogen. Ayan. Now with regards to, let's say oxygen, si oxygen, it has how many valence electron? Nasa ang group si oxygen? Nasa group blank, and that will be its number of valence electron. Di ba nasa sa group 6, tama ba? Okay, very good. Nasa sa group 6, palitan ko na lang yung presentation. Ayan. So let's say this is oxygen. Okay? Sabi niyo meron siyang 6. Ayan, 6. So 4, singly and then paired. Ayan, so 6 na yan. No, 6. 2, 4, and then 6. So kung titingnan mo, meron siyang unpaired. Unpaired. Meron siyang dalawang unpaired na electron. No? So again, para ma-attain yung completely filled outer shell niya, ato siyang i-octet. Okay? So, paano? Let's say, para ma-octet siya, let's try to react that with water. No, water molecule. Kasi sabi dito, dalawa yung atom sa water molecule. Diba? Now, talking about water, diba yung water, ito na. Diba yung hydrogen, rather. Yung hydrogen pala. Yung hydrogen, sabi meron siyang isang valence electron. So, covalent bond, yung mangyayari dito if we react that with hydrogen. Tingnan natin ha. This is one hydrogen. Meron siyang isang. Diba yung hydrogen meron siyang isang valence electron. Okay? Ganon din with the other hydrogen. Meron siyang isang valence electron. So try to check. Okay? Check niyo yung stability ngayon ni oxygen. From 6, diba? From 6 valence electron, na-attain niya yung, check nyo ha, itong part na to. Ang hirap, no? Ayan. Ang hirap mag-discuss ng virtual basta mga structure. Ayan. Yung hinighlight ko na kulay green. Try to count the number of electrons surrounding it. It's already 8. Diba? Mula sa 6, kasi 6 yung valence niya. We represented it earlier nga, 6 yung valences niya. Okay, so now, upon interacting with hydrogen, it now attains its octet state. Meron na siyang 8. With regards to hydrogen, ano sabi ko kanina kay hydrogen? Yung octet hindi applicable, of course, kay hydrogen. Kasi sabi nga, ang hydrogen, it only has 2 electrons, no, on its outermost shell. Okay, na-attain ba niya yung 2 electrons, maximum 2 electrons sa iyahang outermost shell para maging stable siya, attaining the helium electronic configuration? Yes. Diba? Tingnan mo yung each oxygen dito. Let's say yung kulay orange. Diba? Meron na silang, ayan, stable na yung hydrogen dyan kasi na-paired up na yung nag-iisa niyang electron sa 1s. Okay, yung highlighted with kulay orange ha. Kulay, ayan, orange. So yung hydrogen, it now attains, no, its stability also. Completely filled na yung shell dyan ni hydrogen. Okay, upon interacting, sharing its electron with oxygen. No, ganun din yung mangyayari kay dito sa ammonia. Okay, let's check ha. Ammonia, ilan yung valence electron ng ng nitrogen? Ito, nitrogen. No problem with hydrogen. Hydrogen has 1 valence electron. What about nitrogen? Okay, very good. Okay, 5. Okay, so let's try to represent the electrons of nitrogen, no? Using dots. Dots yan usually man, diba? When we represent electrons, surrounding electrons. So we have 1, 2, 3, 4. Okay, then you pair up. 5. Okay, so 5 na yan. On its side, singly muna, you distribute that singly, and then, tsaka ka mag-pair up. Parang sa electronic configuration, di ba? When you fill in p orbitals, d orbitals, dapat singly before pairing up. Okay, pwede nyo yung gamitin yun na concept. So 5 valence electrons. Ngayon, syempre hindi pa siya stable. So para maging stable siya, it tends to interact, no? It tends to form bonds, it tends to form molecules. So halimbawa, magpo-form siya ng ammonia na molecule. So ang mangyayari, merong tatlo daw yung hydrogen, no? Tatlong hydrogen na mag-share ng electrons, okay, sa nitrogen, sa one atom ng nitrogen. So tatlo, ayan. So merong isa hydrogen dito din, isang hydrogen, then another hydrogen. And now you check if na-attain na ni nitrogen yung octet. Yes. Meron na siyang 8, 'di ba? 8 surrounding electrons. Okay, octet na yan. Ganon din with hydrogen. Although hindi yan octet, hindi natin masasabi na octet yan kay hydrogen, but that is the stable state already of hydrogen. Exception kasi sa octet yung hydrogen. Even helium. Kasi nga, dalawa lang yung maximum electrons that can occupy the orbitals ng hydrogen or even helium. Okay? Stable na yan. Kasi it now achieves the helium electronic configuration. Diba? Yung helium is 1s2. Okay? Yun yung resulta ngayon, no, sa electronic configuration ni hydrogen dito upon sharing its 1 electron. Alright? Sige. Let's have another example. Ayan, yung last. Erase ko dito na part. Ayan. CH4, this is the simplest organic, no? Simplest organic molecule, yung methane. Ayan, simplest because it has only 1 carbon. Diba yung methane, it's carbon, 4 na surrounding hydrogen. Okay? Now, ngayon, with regards to formation ng methane, okay, in relation to forming ng covalent bonds, ayan. Okay, let's say carbon, let me ask you muna, ilan yung valence electron ng carbon? Carbon. Okay, very good. 4. So singly, 1, 2, 3, 4. Okay? So meron siyang 4 na valence electron. Ano yung special character ng carbon? Diba? It always share its 4 valence electron. So ang nangyayari dito, 4 daw na hydrogen. Okay? Isang carbon. Okay? So ang mangyayari, ang hydrogen, it will now share its 1 electron to each of the unpaired electrons ng carbon. Ayan. Okay, nakuha. So yan yung concept, no, about covalent bonding. Kung titingnan nyo yung carbon, it now attains its octet. No? 8 na yung surrounding valence electron niya. Ganon din with hydrogen na attain niya yung stable state. No? Si hydrogen na attain niya yung 2 electrons completely filled na outer shell niya. Alright? So that is all about covalent bonding. Sige. Sige nga, let's try to check, comprehensive check daw be. You type in if it is covalent or ionic. Okay? Yan lang yung sagot ha, covalent or ionic. Transfer of electrons. If there is transfer of electrons, ionic or covalent? Very good, ionic. If it is non-metal to non-metal, non-metal and non-metal. Okay, very good. It's covalent. Okay, very good. Paano naman kapag sodium chloride? Sodium chloride, ionic or covalent? Okay, sodium chloride is ionic. No, ionic bond yung bumubuo sa kanila. What about, let's say, fluorine gas? Fluorine gas is F2, no? F2. This is fluorine gas. Is it covalent or ionic? Okay, very good. Covalent. Okay, so we're done with that. Okay, let's proceed to the different types of covalent bond. Okay, although you are familiar on these types of covalent bonds already, okay, diba? We can classify the covalent bonding, okay, based on polarities. Naalala, we can classify again covalent bonds based on depending on polarities. That is why we have a non-polar covalent bond. We also have a polar covalent bond. Now, when we talk about polarities muna, polarity exists, take note, due to differences in electronegativity of an atom. Electronegativity of an atom, property yan ha, property yan ng isang atom. Each of the atom, kung titingnan nyo yung periodic table nyo, meron silang certain electronegativity, diba, na value. Meron tayong mga highly electronegative atom, meron ding poorly electronegative atom. Now, if I were to ask you your knowledge on periodic trend based on electronegativity, if it is going to the right of your periodic table, what will happen to the electronegativity trend? Is it increase or decrease? Going to the right, going to the non-metals, is it increase or decrease? Sige nga, stock knowledge. Electronegativity. Increase or decrease? It is increase. Remember, ang mga non-metals, they are highly electronegative compared to metals. Diba? Metals are on the right of the periodic table. The non-metals are on the left pala. Ang metals on the left of the periodic table. And then the non-metals are on the right most ng periodic table. So increasing. Going up, ganon din, increasing. So the opposite of that trend, decreasing na dayon. If this going to the left, going down, electronegativity, decrease. Okay? Ngayon, kapag ang bond, okay, or let's say the electronegativity, okay, ng isang atom sobrang taas and it is being bonded to a poorly electronegative atom, obviously there would really be a high difference in electronegativity ng dalawang atom. Diba? Kasi bonded already ang isang atom to a highly electronegative one. Okay? Pero kapag naman wala masyadong differences sa electronegativity ng atom, halos equal lang yung sharing. We're talking about covalent bonds pa rin ha. Under covalent bonds ito, yung non-polar at saka polar covalent bond. Kapag almost equal pa rin or equal or almost equal yung sharing of electrons, okay, ng atoms, that is considered non-polar kasi wala masyadong difference sa electronegativity. Okay, let's say for example, identical atoms are being bonded. You try to check in I know you have there your periodic table, or you can search sa browser nyo the electronegativity value ng carbon. Diba carbon has 2.5. Now, it is bonded with the same atom. So when you get the difference ng electronegativity value, it's zero. Walang electronegativity difference. Tama? So if that is the case, non-polar yan kasi wala ngang difference, high difference in electronegativity. Equal lang yung sharing na nangyayari sa electrons. Walang atom na pull masyado ng electrons from another atom. Wala. Equal lang talaga silang nag-share ng electrons upon forming the covalent bond. Diba? Sabi natin kanina, ang covalent bond, sharing of electrons. Magiging non-polar covalent bond yan kapag equal yung sharing ng electrons. Okay? Or almost equal yung sharing ng electrons. Okay, mababa lang ba yung electronegativity difference? Okay? And we actually have a value, no? Parang kumbaga range para a range ng electronegativity difference para ma-consider yan na non-polar covalent bond. It should fall within this range. It's either 0 until 0.4. Considered yan na equal pa yung sharing ng electrons dyan, non-polar. Non-polar, wala masyadong difference in electronegativity. Okay, so another example, carbon bonded to hydrogen. Okay, carbon is a non-electronegative na atom, ganun din. Least electronegative lalo si hydrogen. No? So walang highly electronegative atom dito being bonded. So in this case, non-polar itong bond na to, non-polar. Even if you try to get their electronegativity difference, no? Diba? 2.5 for carbon, and then if you try to check hydrogen, I have with me also here, periodic table. 2.1 naman kay hydrogen. No need, I don't want you to memorize these values, no? You just have to analyze, no? What's the meaning of non-polar, and learn how to identify, okay, by just looking at the bonded atoms, if it is non-polar or polar. Okay, yun lang yung hint nyo. If identical atoms being bonded, non-polar yan. If makikita nyo yung bonded atoms, wala namang highly electronegative dito na atom, then that is also a non-polar bond. Diba? It's 0.4 yung makukuha mong electronegativity difference dito. So, pasok sa non-polar na covalent bond range. Okay, ganun din for carbon to bromine. Okay, carbon bonded to bromine, non-polar din yan. Ang makukuha mong electronegativity difference, it's 0.3 only. Pasok din dito, no? Pasok din dito sa range na binigay. So, non-polar yan. Okay, so yan yung mga few of the most common example ng mga bonded atoms considered non-polar covalent bond. Ang pinaka-obvious talaga na non-polar is kapag identical, no? Kapag identical atom being bonded. Kasi obviously zero yung makukuha mo electronegativity difference kasi parehas na atom yung nag-bond, 'di ba? With regards to polar covalent bond naman, ang nangyayari dito, meron ng high difference in electronegativity. Nagkakaroon na ng unequal sharing of electrons. Bakit unequal? Hindi na pantay yung sharing of electrons upon forming covalent bond. It is because an atom is being bonded to a highly electronegative atom. Halimbawa, ito na lang. Halimbawa ng mga highly electronegative atom, ito na lang yung palatandaan nyo. Mga halogens, ayan. But you also have to consider the periodic table trend, ha? 'Di ba? Sa periodic table trend kanina, going up, increasing. So if you try to check the order ng halogens, sino yung pinaka nasa taas? Sa group 7, halogens. Ibig sabihin, siya yung most electronegative. Okay, very good. Siya yung pinaka-most electronegative among the halogens. You also consider the trend. Going up ng group, increasing yung electronegativity. Okay? Sige, halogens, what else? Nitrogen, oxygen, fluorine. Fluorine nga is a halogen. So yun na nga. Fluorine actually is the most electronegative atom, no, sa periodic table. If you try to compare it with the trend, okay, going up, then going to the left, ibig sabihin, it would be fluorine ang considered na most electronegative. Okay? Now, polar covalent bond, yan lang yung hint nyo ha. Kapag ang atom bonded to either of this, no? Either of this, and then uh, poorly electronegative yung isang atom, then sobrang taas ng electronegativity difference yung i-expect nyo dyan. Kaya polar yung covalent bond. So, halimbawa, si hydrogen. Diba, hydrogen, 2.1 lang yan. Chlorine, it's 3.0, diba? Andyan. Sa periodic table nyo ha, 3.0. So, kung kukunin nyo yung electronegativity difference na it's ilan? 0.9 ba? Tama? 0.9. Okay? So, 0.9, sobrang taas. No? So, pasok na sa range na to. Unequal yung sharing. Bakit ngayon nagiging unequal? Kasi nga, di ba kapag sinabing electronegativity na property, ang nangyayari, ability yan ng atom to pull, to attract electrons towards itself. So kapag si chlorine, mataas yung electronegativity property niya, yung gagawin niya talaga is to pull electrons towards itself. Kaya mapupunta kay chlorine masyado yung electronegativity. Supposedly, we are forming here covalent bond, di ba? Sharing of electrons yung nangyayari. But yun na nga, because of the property ni chlorine na highly electronegative siya, okay, it will try to pull, attract electrons, no? From hydrogen going to itself, going to chlorine. Kaya unequal. Unequal ngayon yung sharing, making chlorine here partially negative, then partially positive here si hydrogen. Okay? So, yun yung nangyayari. Okay? The same thing with ito. Ayan, ammonia. Okay, ganun din yung nangyayari, di ba? Nitrogen, sabi highly electronegative siya na atom. Bonded siya with hydrogen. Kung kukunin niyo yung electronegativity difference, very high din. I think yung nitrogen, parehas lang sila ng chlorine, 3.0 din. 3.0 din yung electronegativity value ni nitrogen. So 0.9 din yung makukuha mong electronegativity difference. So polar, no? Highly polar nung ang covalent bond. Okay, so try natin ha. Diba? This is how we represent kanina ammonia. Okay? So, yung mangyayari since nitrogen is highly electronegative, pool of electrons is really going to nitrogen, making nitrogen partially negative. Ano yung mangyayari kay hydrogen? Partially positive. Partially positive. Okay, so yan yung electronegativity property. Tandaan ha, electronegativity, that is a property of an atom to attract or to pull electrons towards itself. Kaya it is being represented, di ba, by an arrow. Kung saan pointing yung arrowhead, ibig sabihin, yan ay highly electronegative atom. Okay, I'm sorry. Ayan. Okay. Now question, if you are to ask if it is true or false, okay, sa statement. Tapos ang sabi, kapag high electronegativity difference yung makukuha mo, is it considered more polar or polar covalent bond? Yes or no? True or false? Okay? True or false? Kapag sobrang taas ng difference ng electronegativity, polar ba yung covalent bond? Yes or no? True or false? Ano ba? Okay, true. No, it's a true statement. A true statement. Okay? Now, if you're curious, ma'am, bakit until 1.7 lang? 1.7 lang yung range. Bakit pinutol? Bakit hindi na lang sinabing 0.5 and above? Kasi remember, we're talking here covalent bonds. Until 1.7, below lang yung electronegativity difference ng mga covalent bonds. Remember, covalent bonds, it's between nonmetals to nonmetals. Kapag above 1.7 na, listen, kapag above 1.7 na yung electronegativity difference, that is already what bond? What do you think? Na sobrang taas, very good. Sobrang high na yung electronegativity difference, that's already ionic. Ionic bond kasi obviously, you have a cation there and an ion, di ba? A cation bonded to an ion. Obviously, ang pool of electrons is really going to the highly electronegative atom, which is the anion. Diba? Anion, which are usually mostly good. Non-metals, diba? Ang anion. Okay, so that's the reason. Bakit hanggang 1.7? Above 1.7 kasi ionic bond na yon. Ionic bond. And lahat po ng ionic bond, of course, polar. Polar yan. Kasi meron talagang difference talaga sa uh, electronegativity dyan. Kasi you already have, again a cation bonded to an anion. Okay, di ba yan yung ionic? Okay? So I hope you were able to identify now or learn the difference between a non-polar versus a polar bond. Okay? O hindi talaga kaya yung time, no? Supposedly, I really wanted to discuss also the writing of Lewis structures. Okay, let's have that next meeting na lang. Okay, do you have question regarding covalent bonding? Wala? Okay, wala may question. If you don't have any question, I will just like to remind first year students, although you are not under MISA laboratory, please take note na on Monday, limited face-to-face classes will start already for laboratory, laboratory organic chemistry. That's for first year level. So just communicate with your laboratory instructor, Ma'am Jerica Memorasyon. Okay? Or if she cannot respond, you direct your clarifications or concerns to our college chairman, Mr. Roger Z. Basinang. Kasi sila manggid ang ga-attend, si Sir Roger Basinang gid ang ga-attend sa mga admins meeting. Okay? So, igo rami suguon to announce. Okay? Wala kayo may detailed yun. Igo rami hatagan og schedule pod for the laboratory class. Okay? So, mora na siya ang amuang mahatag karon as faculty. If you wanted to have a detailed yun nga ma-elaborate unsa ang need, everything, kay Sir Basinang mumuduol ha. Then about sa inyong laboratory dayon nga class, etc. kay Ma'am Jerica. Okay? Sige, I think wala na may question, wala naman daw na may nag-comment on so far. Sige. So thank you everybody for joining. I'll see you next week. Please expect a short quiz ha. Please expect a short quiz next meeting. Okay, sige. Thank you everybody. Thank you. Bye-bye.
Thank you, ma'am.
Thank you,
Okay.
ma'am.
Thank you,
Sige,
ma'am.
sige.
Thank you, ma'am. Bye, ma'am.
Okay.
Thank you, ma'am.
Okay, thank you. Thank you also. Sige.